In recent years, interest in artificial intelligence has grown significantly, both professionally and socially. The publication of new, user-friendly models has allowed for greater accessibility to a larger audience, resulting in increased virality and faster growth of these models. The use of natural language to interact with models has been a key factor in this scenario. Some of the most famous models have been image generation models, such as Midjourney or DALLE 3. The evolution of these models has been so rapid that it is easy to see how they have improved solving problems as they were used. Initially, the generated images were abstract, but today we have reached a point where it is difficult for an untrained eye to differentiate between an image generated by AI and one created by a person. Undoubtedly, one of the models that has drawn the most attention is ChatGPT. This model has allowed for streamlining work in some sectors, such as programming. However, it is not only useful in the technical field, but also in our daily lives, such as providing us with options for what we can eat today. Given the existence of such powerful tools in widespread use throughout society, Europe has decided to regulate their use through the AI Act, the world's first comprehensive AI law. This aims to achieve better conditions in the use of innovative technology and development. To do this, the law needs to analyse and classify based on the risk of the applications. 4 risk groups have been identified: unacceptable, such as facial recognition or social scoring; high, which would include applications in education, employment and justice; limited, like chatbots or deepfakes; and minimal, which would be applications like spam filters or video games. The European Parliament has provided the main points on which the law is based, such as safety, traceability, transparency, environmentally friendly and non-discriminatory. With proper regulation, the use of AI applications will be safer and provide better conditions for everyone. Artificial intelligence has become globalised across the world and in many sectors. Today it is not uncommon to have devices in the home that use AI, such as Roomba or Alexa. One sector where AI has made significant inroads is e-commerce, where models are used to generate personalised recommendations or detect fraud. The goal is to make people's lives more comfortable and simpler, as is the case of self-driving cars, where several companies are working to make them a reality. However, one of the sectors with great potential for AI implementation is the field of medicine. AI is increasingly being explored in healthcare worldwide, with promising applications ranging from early disease detection to improving diagnostic accuracy and personalising treatments. All of this has been made possible thanks to advances in data technology such as deep learning, which is based on the use of artificial networks with multiple layers to learn from large data sets and perform pattern recognition tasks. To work with large amounts of data, big data has been developed, which is useful for information that exceeds the traditional capacity of database and its management systems. Deep learning is used to process, analyse and deduce key characteristics. Thanks to data mining, we are able to obtain relationships and patterns in large amounts of data. All of this information has to go somewhere, and that is where cloud computing comes in, allowing for storage and shared use of data throughout the internet. It is also used to optimise hardware resources, increase system scalability and reduce IT costs. All of this process surrounds us in our day-to-day lives, in the network of connected devices around us, collecting and sharing information in real time. This is the sector of the Internet of Things. However, all these devices come with a hidden cost. According to Mark Mills, the CEO of the Digital Power Group, over the course of a year, an iPhone hard as it might be to believe, uses more electricity than a refrigerator. Or, for instance, it takes more electricity to stream a high-definition movie over a wireless network than it would to manufacture and ship a DVD of that movie. Tasks involving transactions between memory and processors are problematic due to several reasons. Firstly, the majority of factories that manufacture chips were shutting down during the COVID-19 pandemic, causing a supply bottleneck at a time when demand for computing resources was at an all-time high. Secondly, these transactions consume electricity. For perspective, computers accounted for 2% of global electricity consumption in 2019, a figure that surged to 6% in 2020. Projections suggest that by 2030 this number could escalate to 20%. Given that computing processes contribute to carbon emissions, the environmental impact is evident. For instance, the carbon emissions from computing in 2020 were twice that of the entire year of 2017. To all this, we add the rise of AI, which has led to a growth in data centres, facilities dedicated to housing IT infrastructure for processing, management and storage. Many of these massive facilities have been built by companies like Meta, Amazon or Google, each consuming between 20 and 40 megawatts with 100% uptime. Furthermore, these data centres are used by many other companies since it's cheaper to rent one than build one from scratch. However, the outlook is not all bad. Addressing the elephant in the room, in AI energy consumption, we have Google's initiative which aims for 24/7 renewable energy data centres by 2030. There's also been work on CO2-conscious web design, as every website visit emits CO2 into the atmosphere, with some sites generating from 0.2 grams to 1 gram per visit. Another initiative worth mentioning is solar-powered websites, which have adaptable resolutions based on available energy. In summary, we shouldn't ignore that there is a problem, nor should we stop advancing the field of artificial intelligence. We need to face the issue and seek solutions. As Sasha Lucioni said, it doesn't make sense to burn a forest and then use AI to track deforestation. To continue advancing in development of artificial intelligence application, as we saw in the previous video, hardware is a crucial part of the development of artificial intelligence, which is why the components we have today are so powerful. The video game sector also requires significant data processing to generate high-definition, three-dimensional models. While processors were traditionally used, better results are now obtained with graphics cards. The CPU is a logical gate processor that handles low-level instructions in a computer system. It is flexible, precise, and allows the use of cache memory, but is not good at processing data in parallel. On the other hand, the GPU can work in parallel and can be specialised for specific cases. This is why, for most AI applications, GPUs are used, as they require parallel processing. In the example, we can compare the time it takes for a CPU and a GPU to obtain the inverse of a matrix. But why is all this processing necessary? Let's talk about convolutional neural networks in order to understand. These networks are widely used for image processing in deep learning. Their strength lies in their ability to detect patterns. The main difference between multi-layer perceptron neural networks and a CNN is their hidden layers, called convolutional layers. These are responsible for finding features in the images that the model is being trained on. The first layers specialise in more general components, such as geometric shapes, textures and edges. On the other hand, the later layers will find more specific objects such as eyes, ears and feathers. In even deeper layers, it may be possible to detect dogs, cats or your Fortnite avatar. To better understand this process, let's see how a filter to detect edges works. We will use 4 matrices with dimensions 3 by 3. If we look closely, all of them have a column or a row with value -1, another with 1s, and the last with 0s. If we make a visual representation of these matrices, we can associate the colour black with -1, white with 1 and grey with 0. Now we convolve the avatar images with these filters, we will obtain the following outputs. The first matrix detects the upper horizontal edges, the second detects the left edges, the third detects the lower horizontal edges, and the last detects the right edges. This is just one of the many techniques used in deep learning. Another powerful tool is transformers, which were developed to solve the problem of neural machine translation. This means any task that transforms an input sequence into an output sequence. This includes speech recognition or text-to-speech transformation, among others. In order to achieve this, it is necessary to have some sort of memory. If our interest is in generating images, then we have generative adversarial networks, which are used to generate realistic synthetic data. These models use a two neural network architecture, one generator, one discriminator, that are trained together in a competitive process. Another powerful tool used in many sectors of deep learning is transfer learning, which is used to transfer knowledge from one trained model to a new one. To do this, the layers of a pre-trained model are recycled to obtain features, and then the final layers are modified to obtain a new model. We could use a model that detects cats to generate a model that detects capybaras, for example. With this, we have been able to provide some insight into artificial intelligence and provide context to the current moment and why this sector is so important. We hope you have enjoyed the videos and that you have learnt something. We hope to see you soon, and thank you very much.